Okay, so we're looking at the HIV, and we look at this table, and we see there's 526 who tested positive, and of those 526, 37 of them really don't. So that gives us a probability of 0.074. So that's a pretty easy way to solve that problem. And then, okay, and so then we look back at part B and figure out what they're asking for in part B. And in part B, it says, among the blood samples examined in the training program that provided positive ELISA tests for HIV, what proportion actually contained HIV? Well, once again, this is probably where it's going to be beneficial to have this table ready. And our table says, okay, part B said provided positive ELISA test. Well, we had 526 of them that were positive, and of those, 489 have it. All right, so that gives us a probability of 0.927. So that meant the table was pretty valuable in that particular situation. Now, I will have to say that problem C is substantially more difficult. And so when a blood sample yields a positive ELISA test, 2 more ELISA tests are performed, et cetera, et cetera. And so here's the way I would approach this. First off, I would be sitting there considering that I have to have an initial positive, and that initial positive when they walk into the lab is 0.074. And then I need to have 2 more, or I need to have 1 more after that. So if I'm initially positive, I walk into the lab and I test positive, regardless whether I have it or not, if I test positive, then I'm going to get sent on for another test. Well, in this case, we are wanting to know the probability someone who tested positive but doesn't have it actually goes on. So I need to sit there and go, what's the probability? Well, we answered that in part A. So we have 0.074. So now we need to deal with the other part of this. And we're going to go ahead and stop the share and end the meeting.